Welcome to qnawire.
Okay, we are identifying stereoisomers, and then we're going to count the number of possible, stereocenters, and then we're going to count the number of possible stereoisomers we could have. Right, so how do we identify stereocenters? Anytime we have a carbon which is connected to 4 unique substituents. Right, so right off the bat, anything with a double bond we can rule out because those won't be unique substituents, right? So we can rule those carbons out. The other thing we can rule out is methyl groups, right? Because methyl groups are attached to 3 hydrogens, so it can't have 4 unique substituents. So I'm going to rule out all of these methyl groups. Okay. The other thing we can rule out is these edges of rings in which we have only 2 bonds to carbon as part of the ring, but then implied is 2 bonds to hydrogen. Those can also not be stereocenters because they can't have 4 unique substituents. Right? So these green centers are not stereocenters. These are all my CH2s. I'm ruling out all the CH2s. Okay, there's another sp2 carbon, right, or a carbon with a double bond. Okay, do I have any remaining CH2s or sp2 carbons? I don't think so. Okay, I guess we can rule out non-carbon atoms. It can't be sulfur, can't be oxygen. Okay, and now we can look at our remaining carbons and on a case-by-case basis decide if they are connected to 4 unique substituents. I think this is, right, because this ring is not symmetric, so each side is different. This bond is to a completely different ring, and this is to a methyl group. That's 4 unique substituents. And it's a similar idea here, right? Carbon that's not the same. All 3 of these directions are unique in terms of what their point in the ring is. There's no like symmetries that would make this direction the same as that one. And then we have a single bond to hydrogen, right? So that's a stereocenter. This is a stereocenter. This is a stereocenter. This is a stereocenter, right? And finally, this is also a stereocenter. Okay, so how many stereocenters did we identify? I count 1, 2, 3, 4, 5, 6 stereocenters. Okay. So how many possible diastereomers could we have? Well, the idea then is that we could have R, 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 R. That would be 1. Then we could have S, R, 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 R. That would be another. Then we could have R, S, R, 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 and so on and so forth, right? So every single one stereocenter that we identify could be one of 2 things, right? So basically you just get 2 to the number of stereocenters, which is 2 to the 6th, right? So 2 to the 6th is 2, let's see, 2, 4, 8, that's the 3rd, 16, that's the 4th, 32, 64.